Hey guys, welcome. Unfortunately this video was not the dyno video that I wanted to do. As much as I want it to be the dyno video, it never actually happened. About 4 weeks ago the car went on the dyno and we had major issues out of the first day that was on the dyno, out of the 2 days the car was booked in. On the first day the boost controller kept freezing again. I've had this issue every time the car's been going down to the dyno. About halfway through the day, the boost controller just freezes just on the spot when we're pulling a full pull on full boost, and so really couldn't suss the issue out on the first day. I came back home, about a 2-hour trip, and took a couple of tools with me, as you've seen on Facebook and that. I've had a lot of trouble with this EMI, it's electromagnetic interference, which does cause a big effect on electronics. So I took the car back. Took the meters and that back down the next day, back into the city, and just before we went to the dyno in the morning, we also picked up some ignition cable, some better quality ignition cable, because the cables that I've been using with this plasma ignition, you have to use non-resistor cable and for the plasma to work. Problem with using non-resistor cable, that it gives off a lot of interference. It doesn't suppress the high voltage interference from the coil. So basically I had to discard the wires that I was using the plasma for now, and we just had to run with the standard coil and use this high quality MSD suppression cable it is, and that suppresses the electromagnetic interference from the actual ignition cable. And that's the only thing I could think of at the time that was causing the effect, and that's the highest voltage on your car that's being produced. You know, everything else in your car is 12 volts, and coming from your coils you're dealing with 30 to 40,000 volts. That's where the wheel's pushing it pretty much at full power. So we had to actually gap plugs down a little bit, you know, just because the spark wasn't able to jump the gap because there just wasn't enough voltage being created from the coil. So we changed the cables over on the second day, and we started doing pulls, and that was it. We actually solved the issue of the boost controller freezing. So for any of you out there that have actually experienced interference or electronic freezing and stuff like that, change your coil plugs, change your wires on your coils. That could be the reason why something may be getting interference. There's nothing else in the car that can produce that much interference. On the first day we actually froze the dyno's computer 3 times, plus we also froze the computer that was in the main office. So this is just crazy amount of interference. That was just being created just off the ignition wires. That's all it was. So on the second day, once everything started looking good, we started winding up the boost, just running a rich air fuel mixture into the car. We started upping the boost from 20 to 25 to 30 pounds, just to see roughly where we had to push the turbo to get the power we was achieving. The goal is to achieve 400 kilowatts at the wheels on this motor on high boost. Now, when we started pulling 30 pounds of boost on the day, basically the head gasket, the head bolts that were used in the motor were not strong enough. We found out that the only standard ones were being used and they weren't going to handle the power that I'm trying to push out of the motor. So I have to pull the motor apart and change some ARP bolts to an ARP stud kit. But on the day, what was happening was the bolts are stretching under full boost, 30 pounds. The bolts started to stretch just a little bit and the head gasket started to break its seal. So the actual compression, or the air that was bleeding past the gasket was going into the cooling system, and that caused the radiator cap to lift open a bit because there was extra pressure in the cooling system, and then the overflow bottle started to leak out onto the ground. Unfortunately, I don't have any video footage of the car on the dyno, just to the sheer fact that we had not much time on the dyno that day because other customer cars were getting booked in, and I just thought that we still hadn't solved this interference issue, but we only took about 6 pulls and then we're sort of up to 30 pounds of boost, just trying to get a rough idea of what the car wants to do, and we end up making 376 kilowatts at the wheels with still ignition timing to be even touched with. The cam gear's still set on 0 degrees, we can still dial them in. The air fuel ratios can definitely be trimmed up a lot more. But yeah, really, that's where it's at. So, brought the car back home, and started to really think, why did it take so much boost to make that much power? Is there a reason why or not? On the dyno graph, I actually noticed that the boost curve started to drop off just a couple of psi at the end of the power curve. So something in the exhaust system is obviously a restriction. So I want to have a look at that, and also the intake side of things. If you've seen on the Facebook pages and that, I wanted to change the fuel injector position just for a better spray, better mist into the ports of the head, just so I can get a better atomization. So hopefully that will increase a better burn in the combustion chamber and make a bit more power. With doing so, how I fitted the injectors into the runners, they protrude the intake manifold runners a fair bit, and they might create a little bit of turbulence, but it's not showing up on this little flow bench that I've made here. This little flow bench I've recently just finished knocking up, if you've had a look on Facebook and that. It's just a home built thing, it's just a tool just to show me what's going on inside the manifold. It doesn't pull big vacuum like a proper flow bench does or anything like that. I just want to see what the air wants to do inside the manifold freely, not under vacuum, just free flow, just see what it wants to do. So that's what this is, just a home built little tool, which is just to show me what's going on, and for future projects that I want to put up on this channel as well, modifying other intake manifolds and doing comparisons and other stuff like that. But anyways, for now, right now where the car is at the moment, I want to make sure the air is getting evenly divided into all four runners from the throttle body. And with this intake manifold, when I first got it made, as you see in the pictures and other videos, that I've got the water to air intercooler sitting in front of the motor. So all I need to do is put a 90-degree silicon joint from the intercooler to the throttle body. So there was no need for this throttle body to have the 20 degrees that they normally do on a front mount intercooler setup, just because of how the pipes are routed through the front guards with the holes cut out in them. So really all I wanted to do was just make the intercooler piping as short as possible, try and make less volume as possible, and hopefully that was going to make boost come on a little bit quicker. Also with the manifold, when I originally got made up, I had the initial thought that I was able to port the head out to sort of like the 4-port C18 heads, but the engine builder didn't want to do that on this head because it's not really suited. It is a different type of head, and for the fact that I got told that it was going to create a lot more turbulence near the valves, so they wanted just to adapt basically adapter plate from a 4-port manifold to an 8-port head. With this adapter plate, as you can see, basically it's about almost a good 1.5 inch thick, or 1 inch thick sort of thing, and this pushes the manifold out further away from the head. When doing so, they actually pushed the manifold into the clutch reservoir, so I had to get the back tapered off the manifold here. Normally there's another 1.5 inch of plenum back here. So with doing this, what's happening now is that the air is coming through the manifold and it's smashing into the back of this plate, because this is just, the throttle body is just horizontally straight across all the ports instead of on an angle where it slowly helps distribute the air into the ports. And because I needed the back plate to be shortened so it could actually fit in the car, in the engine bay. So with all these modifications done, it's resulted in a fairly poor manifold flowing design, originally from when it's first came, when it was first manufactured sort of thing, when it was first built. So the changes that I've done have had a big effect on how freely it wants to flow air. So this is something that I need to have a look at, and I want to fix up the injector side of things with the positions, because the injectors protrude the runners a fair bit. So from now, this is where I am. Going to try and do a few videos of making and building this new intake manifold. I want to try something different that no one's done before. Try and actually collect all the air from the throttle body into a small area where all the runners can then grab the air into the head, rather than having such big spacing across all the runners and a big area that the air has to distribute from the throttle body. It's just got so much area that it can move around in the throttle into the plenum. So I want to try and see if I can concentrate all the air coming from the throttle body into a smaller area where the runners can then pick the air up. So hopefully this will help distribution a lot, and hopefully naturally the air wants to flow that direction better rather than coming in on a 90-degree angle and then having a very sharp radius going into the runners. Hopefully with having it more straight, flowing, not as less aggressive bends, this will result in a lot better, smoother power curve. In the lower RPMs is where I'm suffering big time. Boost on this car is coming full boost at 30 pound by 5,000 RPM, and we're revving it out to 8,000 RPM. But anything below 5 grand, pretty much 4 grand, is pretty much nothing. So I need to try and find a fair bit of power just to try and make it a lot more responsive and a lot more enjoyable down low. So that's where I am at the moment. A few next things I want to do in the build is the exhaust side. I'm having a look at that, and with making 400 kilowatts plus at the motor, you got 100 kilowatts in under 500 cc's of volume. So there is a crap load of air that's coming out of one of those exhaust manifold runners or ports and the pipes. So I want to try and make some bigger pipes just to flow the extra amount of air, so that the actual exhaust manifold itself is not a restriction. The only restriction is the cylinder head and the turbo, where it's going to make boost, which is where you got to build pressure from. So in the next few videos, once we've made the intake manifold, it's going to be some serious work on the exhaust side of things on this car. So pretty much going to try and make a lag-free turbo setup. So still working on and looking at flow charts and that on Garrett's site and doing calculations, but pretty much nutted out what I roughly need. So just trying to look at exhaust flow sort of things on that side of things. But with the turbo that I got there now, the exhaust housing definitely looks like it's a little bit too small at the high RPMs. We are losing a little bit of boost, a couple of pound, I think about 2 or 3 psi, just very slowly across the rev range from when it comes on. So this could be fixed easily with the boost controller, but naturally something else might be a restriction in the exhaust side. So I want to fix that and want to try and make it as best as possible since I've come this far with the build. I want to take it that next step further, which is going to try and push it further and be real unique. So that's where I am. So at the moment we'll do a quick video on showing what I found with making this little flow bench and just go over how this little flow bench has been built and what I've used, and yeah, we'll go from there. Okay, so as you can see, this is a little flow bench that I've made up. Just some steel tube frame, just some MDF wood. Got here, I'll start from the back. Just for what I'm using, just to flow the air through, I'm just using these little 120mm servo fans. They're called Delta fans. If you guys are into gaming PCs and stuff like that, I don't mind a bit of that. You actually notice what these fans are. They're Delta fans. They're pretty much the powerhouse of 120mm fans for the airflow they flow. Each one of these fans flows 250 CFM, which is claimed on the good old sticker on the motor, so whether it's true or not, don't know. They definitely pull a hell of a lot of air. They spin at 6,000 RPMs and they pull 4.5, nearly 5 amps at 12 volts. So for any of you guys that know a little bit of voltage side of things and amperage, that's a hell of a lot of amps for a tiny little fan at 12 volts. So just using a little 12 volt power supply just for it, just to power them on and off. Had a vacuum gauge which does nothing because they don't pull enough vacuum. So maybe later on I might look at a better motor, so I can maybe start pulling some decent vacuum. I'll probably have to put some thicker MDF on the sides just to handle it. What I'm using to read the airflow is these anometers. Actually grabbed the idea off of someone else's channel, and I'll definitely thank him for that idea because that was really good. I'll throw a link in the description where I got it from. the ones I'm using are Fluke brand, just for high quality, and just really couldn't be bothered messing around with the cheaper stuff because I really would like to make this little project last as long as it can. So what they got inside of here, this gives you all your readouts. So you power them up and you can calibrate them to the area of the tube that they're sitting in. You just got to get the area of the radius or the size of the tube. These are 70mm tubes, so calculate the area of the 70mm tubes, and then you program that into this little nanometer here, and then that, that's 0.041 cubic feet. That's what it's set up for at the moment in these tubes. So you can program it, you can get your CFM, and you can get your velocity and that in there, but all I want to know is just CFM at the moment. Down here, we'll start here as well. It's just a big box inside just to try and even out pressures and that. In here is a really nifty idea, which is from the other guy's channel. Just some PVC piping, and these little, with the PVC piping, you get these little adapters that come in here. I'll just grab this. So, as you can see, the little fans, that's what spins. That's how you get your reading. Obviously there's a little signal which gets sent to the little hand controller, and then that tells you what you're roughly getting, going by the area and the airspeed of the hole that it's in. And they roughly just sit inside. This one's not going in. There we go. You roughly sit that inside of here, and you put your end cap on with the hole obviously untaped, and then you just tape them all up. Just try and make it airtight, and that way you can flow like throttle bodies and other things if you just want to quickly get an idea of what that flows. So in this case I wanted to know what the throttle body roughly flowed by itself without the manifold, and then when I put the throttle body on the manifold, I compare the readings of all four that's flowing through the ports, and basically I can see if the manifold is a restriction or if the throttle body is still a restriction in the flow side of things. The adapters, what I've got under here, you got a piece of board which is here, and this is removable, so you can cut out another piece of board which will suit the different type of manifold that you're going to make. So if you've got a V6, which I had, which is back here, so the other build that I had was to build a V6 manifold, so you can just use one of these bits of board, cut out what you want, adapt your PVC adapters to them, then you can put that onto this table. Remove this, take your clamp off. This is a little clamp just to try and hold an airtight seal. In between the two bits of wood there is a little bit of weather strip foam, so try to make a bit of a seal on that. This is a jig, so on here what I've done is I've made this base jig which slides down onto these four corners just over top, and they get held down just with a little bolt going through, so that holds it down, and then the clamp holds the actual adapter board onto the actual bench down nice and tight. So with the V6 jig, you can just lay that on top of these two pipes just here, but for this one I wanted my manifold to bolt up just onto the side, so I ended up just bolting this 90-degree bit of pipe work that I made up, and sits in there really well. So I can just change from a 4-cylinder, take these off, remove that, take the board off, take the clamp off, and then put the V6 one on there, put that on, and just sit the manifold on this. This is all I do, is just sit the manifold on top of this, and all it needs to do is stay there. And then just to adapt the port work from there, it goes down to the board. So that's that. That's pretty much the flow bench and how it works. There's not much else to it really. Pretty much all it's there to do is just to show you what's going on inside. And one thing I wanted to do is, I haven't seen a flow bench which flows intake manifold like this. Normally your flow benches, they got one port and you got one readout. What I wanted to do was to flow the whole intake as one and then read what each individual runner is getting, so that I can see literally what the air is doing inside. Because normally I think what might happen is they'll flow like one runner at a time. So what happens if you flow one runner at a time, the rest would be sealed off. So this one runner is always going to get plenty of air. There's nothing else robbing that air. So that sort of wasn't like a true reading. And then the other thing maybe they could do is flow the whole intake manifold as once. So, I don't know. I haven't seen any other flow bench like this on the net. I can't find anything when I was hunting around. So I ended up building this because I couldn't find anything around, and wasn't too bad. It's done the job. So that's pretty much an overview of the bench. Let's do some testing. Okay, so we're about to start up and do a test, and one thing we're going to try and do is, one thing I noticed is the flow difference when you start moving the throttle body around. That's actually quite interesting. So I'll start off with throwing the throttle body wide open, and then we'll start gradually closing it. And just take notice of how the flows change across all the cylinders as the throttle body changes its position. This is actually quite something interesting, and should be going to have a look at it more thoroughly when I make the new manifold to make sure this happens minimal. You actually see number one cylinder starts to lose a lot of airflow as we start closing up the throttle body from wide open to quarter, like 3/4 to half to 1/4 open. So I'll just got the little GoPro up here. That's going to roughly show you where the throttle position is. So start recording this now. Okay. This is so unprofessional. I suck at doing these videos in front of a camera. I'm not one for a person to stand in and get a photo, let alone do a video in front of all you people. So I'm trying my best here. I've got the old nerves on a little bit. I'm out of my comfort zone. So anyways, this is number one cylinder, number 2, 3 and 4. So what we'll do is turn him on. Now it's not perfectly airtight. I still need a little bit of tape or something just around the little lips here. There is just tiny little air gaps, so you do get a couple of CFM reading on the actual meters when the throttle body's closed, but the throttle body is open a little bit as well, just so the car could idle. So that's where maybe some of the air is coming from. I haven't really played around with it, don't really care. And that's not flow. There we go. I only just turned these on. These are velocity readouts. Okay. So this is CFM. Cubic feet a minute, as you all know. Alright. So let's go wide open throttle. As you can see, we've got 48, 49 CFM, we've got 64, 66 and 77. Now roughly this is 32% difference of airflow from number 4 to number 1. When the car's running, all the fuel injectors are spraying the same amount of fuel in each cylinder. So this flow bench isn't pulling the same vacuum as a motor does, but this is actually flowing the same amount of air as to what I am on 30 pound of boost right now, as I've worked out. So at wide open throttle, you can see a 32% difference roughly from number 1 to number 4. And the middle cylinders actually aren't too bad, they're pretty spot on, like comparing just the twos, the middle ones. So as we start to close the throttle body, very slowly, you can see the difference in the drop. We're pulling 92 CFM now in number 4, and I'm only getting 20 CFM in number 1. This is just by moving the throttle body just a touch. It's pretty much still straight open. The throttle body on this, for some reason, is actually angled up a little bit further than horizontal. It actually goes past horizontal, so when I actually level it out, the actual air wants to come back down. So now when I start to close it off a little bit more, you can just see the difference. And it's pretty interesting how the throttle body is shaping the air inside, as you can't see it, but you can sort of tell what it's roughly doing now. Naturally, that's what it's doing. So all 4 ports are connected to the same box and they're all pulling the same vacuum, yet this is the direction that the air wants to take, the easiest path in the manifold. So in this design one, so as you can see, we're pulling 65 CFM now. What are we? We're still pulling 72 CFM. It's hard to see with these screens where I am. I'm having trouble to see it. The back one's 73 CFM. I'm pulling 4 CFM the front one. So the air's just completely missing the first cylinder, and we're getting pretty much the same sort of airflow across the middle ones, but we're still pulling 70 CFM across the back one. So as we start to close it off a little bit more, slowly, it's still roughly the same percentage wise, you know, in drop. And now these cylinders are sort of getting closer together as the throttle body closes up even more. As you can see, 19 and 11 CFM, 29 and 37, so throttle body really manipulates the air on different loads where your foot goes on your throttle. So it's still going down just slowly. Pretty much got the same air distribution now across the 3 cylinders. Still not much in number 1. And then that's just about it. So this is something that really showed up, and that's completely closed. But as you can see, when we go wide open throttle, you get not too bad a distribution between these sort of 3 cylinders. Yeah, it's not that far out from number 1 to number 2, and the difference from number 4 to number 3, it's not hugely far out. But it definitely is a massive difference from the back of the motor to the front of the motor. What this is showing, reminding that I haven't got any valves or anything like that which is restricting the flow. This manifold is flowing the same amount of air as to what my turbo is pushing at 30 pound of boost, so it's roughly the same worked out. And as you see, I only have to move the throttle body close just a little bit, and the air path just goes completely off the direction where you want it to go. So that's pretty much what I wanted to show you, and what I'm doing now with the car and where it's at. And hopefully I can definitely make up a new manifold which will eliminate or help out a lot more when the throttle body moves around. This is something that I'm going to have to try and suss out, try and make a different shape of the manifold or something. So this one's going to be different from, rather than just flying a manifold at wide open throttle and just seeing what the air wants to do, it seems to be now going to be a bit of an act to try and make the air distribute evenly when you're at half throttle, 3/4 throttle, which is what you do a lot of the times, is always playing around with the throttle, especially when you're racing or whatever you're doing. So if I can naturally flow the air evenly at any throttle position into all 4 runners, then that's the goal. That's what I need to try and chase. So that's where it's at the moment. That's where I am at. That's where the car's at. So like I said, later on, going to do more videos. Hopefully I can make some more videos talking. Hopefully I can get that better for you guys. This isn't my natural thing. This is, like I said, I'm not a person that's into taking photos, let alone in front of a video camera, but it's something that I want to try and do for you. So, and I want to do this just because you can. So yeah, that's where it's at. We'll make a new manifold. I also noticed with the intercooler, I actually connected the intercooler up to the intake manifold with the 90-degree silicon joint that I use, and I actually lost volume. So what this means is that the intercooler is a restriction now before the throttle body. So the core of the intercooler, the surface area that the air has to go through is not large enough. So I think I lost around 30-40 CFM going by what this is showing me. So that's probably like a 1 or a 2 PSI difference from in between the turbo and the intercooler from the intercooler to the throttle body. There's a difference of an extra maybe 2 PSI more higher than what's on the other side of the intercooler, what's after the intercooler. So what's before the intercooler is probably a couple of PSI higher than what I'm getting in the intake manifold. So what that translates to is also more exhaust back pressure. The more boost you run, the more exhaust back pressure you run in your turbo side of things, your turbine. That's the thing you got to think of as well, is that the more boost you're putting into the motor that's on the intake manifold, the more exhaust gas back pressure you have on the exhaust side. So you want to try and balance it out and get that as low as you can, and I think that's up too high at the moment. That's why I started losing PSI on the dyno sheets. You can have a look at all that on the Facebook page that I got. I'll throw all that sort of stuff up, like the photos and that, and give a little description out. So have a suss at that if you're interested in the power curve. Once we made boost, like, just hold it flat, and it was pretty awesome to see, and it's good to see that the car's going to make that power pretty easily. Just want to try and get the boost pressure down a little bit, fix up the exhaust side, hopefully we can get that free in a bit more air. Hopefully that'll create less exhaust back pressure, gain a few more ponies off of that, and go from there. But yeah, the next couple of months with this build are going to be pretty nuts. So that's all I can say. Has to be a new intercooler setup because I want to lower that PSI drop and get that the same, so I have pretty much no pressure difference from before the intercooler to after the intercooler. Get the intake manifold flowing nicely, and I also want to get the injectors position much better. Hopefully I can get the spray a lot nicer. We got it pretty damn good now, but because I want to make a new intercooler, I definitely want to fix that up and make it as best as I can. Just to try and cram every kilowatt we can out of this car with as less boost as possible, just to try and make it as efficient as possible. Also going to be doing exhaust gas temperature install on this, on each exhaust runner. So I'll do a video of that and show you how to install that sort of things. Go from just welding little bungs on there, running the cables, and hopefully we can document that on the dyno, and that should relate into how well the intake manifold flows. And what this is showing is that number 4 cylinder we're getting around 70 CFM, and number 1 cylinder is getting 50. Now the motor itself will pull a lot more air than what this can, but this manifold naturally wants to show that all the air wants to go to the back of the manifold, and I need to try and concentrate that more in towards the middle and definitely get what's left onto the outside of the 2 ports. So what this will translate into is what's happening now is that the back cylinder, because all injectors are injecting the same amount of fuel into the motor, but the air CFM is different across all the cylinders, that you're going to have uneven air-fuel ratios. And now one thing I've always thought of is just tune the motor, tune it to this air-fuel ratio, and that's it. Now I'm sort of thinking, okay, we're making a lot of power out of this motor, so what I want to do is need to make sure every single cylinder is getting the exact right air-fuel ratio mixture. So that's key. So the exhaust gas temperature sensors are going to be key into making this be as reliable as possible, because what would be happening now is because number 4 is getting a lot more air than number 1, but they're all getting the same amount of fuel, that number 4 will actually be running lean, and the exhaust gas temperature will be a lot hotter than what it would be for number 1. Number 1 would be a lot colder, have a really shitty burn, won't be burning all the fuel off. So that's the power loss there on its own. The 2 middle cylinders, they're probably pretty much spot on, and then the back one is lean, and that'll probably sort of make up that sort of air fuel ratio on the one oxygen on the oxygen sensor in the exhaust side of things. So this one's lean, this one's rich. Those 2 cylinders might even themselves out and give you a roughly okay air fuel ratio when each cylinder is wrong, and the 2 middle cylinders, they should be fine. So this is something I need to try and concentrate on now that we're making big power, that any little detonation, little ping, any little wrong mix of air fuel at this power level with this such a small displacement engine will result in catastrophic damages basically. It's not like having a big V8 which is making 100 kilowatts and it's pinging its head off, but it could do it all the time. But now you're making serious power, that little ping could turn into a bomb, so that'll throw a rod out the side or punch us through the bottom of the sun. So now it's just fine tuning. The higher the power we're getting, it seems to be fine tuning a lot of this stuff, and that's what I'm trying to do now, is trying to understand that sort of thing and try and make it as reliable as possible. Really want to push the most out of a little 4-cylinder and see what can actually be achieved out of them. So that's where it's at. Hope you enjoyed it, hope you learned some things out of it. I'm still learning as I go along, but like I said, the future builds, hopefully soon, get some holidays and get some videos rolling out. Intake manifold will be done, new intercooler will be done, exhaust manifold has to be done, much larger pipes, get some back pressure to drop down, and some new turbo setup. So it's going to be, don't want to reveal it just yet, but yeah, almost going to be lagless turbo setup. So hopefully soon we can actually make a completely sort of unique motor that no one's sort of seen before. So just trying to study it all up at the moment. So hope you guys enjoyed it. Hopefully I didn't drag it out too long. I know I get boring listening to, but these are the things I'm finding out and these are the things that I'm doing. So thanks for watching, and hopefully we'll get some more things happening shortly with this build. Alright, cheers.